Good morning. Good morning. Oh, see, there's that lighting again. Yep. Okay. Good morning, chat. We're getting a little fuzzy over here. Let's see if we can adjust that. I think we just need a little bit more light on that side. Yeah, we are. We're moving up in the world now. Now to be honest, it's actually been like kind of a journey to figure this out. It's pretty wild. Um, every time I like do something like this, like every time I upgrade part of the stream, I'm like, man, this is really hard. Like this is really tough. And it's just such an easy rabbit. Oh, I was like, did I roll over the thing? No. Okay, cool. Yeah, so it's fine. It's good enough. I think we could probably just. I just look red. I wonder if I can. Let's see. Probably change the color of that light. Yep. So can we do a little? That's good enough for me right now. If it gets annoying, someone let me know. Um. Okay. Well, good morning. How's everyone doing this morning? Yes, and I do have a replacement stream. I'm gonna be gone for a little bit. So I wanted to make sure that I could, get that time in, before I left, basically. So, all right, cool. Let's let me send out a quick tweet, and we will be on our way. We'll be halfway fun. I like to think so. Um, do, 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 do. It's I'm visiting my partner for a few weeks, so that'll be good. Um, let's see. Yeah, definitely good times. Yep. Yep. I'm looking forward to it. There it is always really nice. I try to go fairly often. Um, but yeah, so I'll be doing that for a couple weeks. I'll be home for a couple weeks, and then I'll be at GitHub Universe for a little bit. So anyone in San Francisco, let me know. All right, let's get this going. I'm gonna turn down my music on my end a little bit. It is a little fun, but it's a little it's a little weird. All right, so let's take a look at the changes we've been making to this thing. I moved it. All right, yeah, there we go. Okay. All right, so I last week we had or last on Tuesday, last stream, we had a big issue with why I couldn't print things out. And I found that issue. So here, it's a weird one, so we'll walk through it together because I think that for people who are interested in Zig, you're going to kind of want to know what's going on here. So, um yeah, there we go. We're printing out a lot of atoms, right? So, here's what happened. HashiCon is next week, and GitHub is right after that. Yeah, yeah. So that is the thing. So I was like, I debated going to DockerCon. I don't do enough stuff with HashiCorp to do HashiCon. I'm really excited if they do a NixCon in North America, which I've seen. There's a lot of discussion about that. So if that pops up, I'm definitely interested in that one. But yeah, it's like yeah, there are a lot of cons. I think it's like this thing of like after things reopening and stuff with COVID, like there's just a bunch of cons. Like everyone's there. They're like, oh, let's put on like 8 different ways to network now. you know, so I don't know. I think it's also that time of year. Like I just feel like there's more this time of year than there are other times of the year. So yep. Um. All right. So where was this print? All right. So this is really what happened. Um. The When we have strings in a language like C, right? And in Zig too, because of how its memory model is. We When we have a struct that has strings as values or as fields, those values can disappear if the memory is out of scope, right? So if we're expecting it to be on the stack and we're not like ensuring that it's there, it will probably just disappear, right? Which is what happened here. So what was happening was is we weren't actually storing the atom records in anything. So when we would convert to the atom record, we weren't actually storing them. We weren't allocating any memory for them. We were just storing them on the stack, and then when we would return from adding it, the stack frame would get returned too. So the reason it would work is sometimes we would have it where it was not that, right? So what I mean by that is sometimes you would have it where the values were actually accessible, and that yeah, that's what happened. Um, so yeah, that basically what's happening was we were removing the values before we actually could do anything with them. Um, but it was and the thing is like when you do a thing, when you convert something to an int or a float, those values are raw conversions. They're not just like parsing. So like in this case, in the remove spaces, we're actually just taking a string and we're cutting it up, and we're going like, okay, this is the string, and we're cutting the pieces. Um, and that's fine, except for the fact that when your original content goes out of scope, you lose it. So in this case, what we had to do instead was we have to do an allocation and copy that value into it, and then that way we're doing it. So that's kind of the bummer on that part is like if you actually want to do anything with it, we do have to do a mem copy. I think there's probably a way we could do it on the stack, but I don't know what it is yet. And I'm honestly, I kind of want to move on to this other file type, and I think that we'll get there soon. But I think this is like good enough, right? So we get this like remove spaces, remove spaces, remove spaces, remove spaces. So now that works fine. And boom, there we go. Now we can print out stuff. Yep. I think I probably need to check this actually though. So let's see if Outlook. Um, so let's modify print. Did we include the alt location? Yes. Okay. So let's add it here. Yeah, I want to redo how we do this print. So maybe we can actually do that first, just because I want it to be a little more useful. Self star atom record. Why am I dropping so much today? My encoder is having trouble today. It's really having a hard time. Weird. Okay, so it's not going to return anything. We're going to do... Nope, that's not what we want, Copilot. That's kind of what we want, but not exactly. We want to do this. We're going to do this for... a type. Huh. Weird. What did you say? Did I miss something? Oh, on the screen, like on Stream Elements. Interesting. This is why you need to stay away from the little languages. Yep. Yeah, you and me both. So that's the. I probably should. Um, but it. Uh, they are fun. They are interesting. They do teach you a lot, right? They kind of force you to think about what you're doing a little bit more closely. Why is my stream dropping so much today? All right, let's do this. Switch on field dot uh, field. Nope, it's not len. It's type val. If we're gonna do like a switch on. Yep. Okay, so I will say this. I did go through OCS, or I went through a computer engineering program in college. Um, and for that part, I I'm gonna be honest, I did not do very well with understanding computer architecture. I did a lot more embedded work. I did a lot of like low level stuff that's kind of different than this. So like in that case, maybe you might not have a stack or a heap. So it's a little bit different um, to work with, but it's kind of been interesting to come back to this after I had done that. So what was interesting about that is I kind of I learned it as I like kind of was more actually just with Zig. Like, to be honest, moving to a language like Zig has kind of forced me to re-look into it, rework on how all of that works. Yeah, exactly. It's like always, every time you're like, you see someone, it's like, oh yeah, it was because I was doing like robotics or something. Like that's always like the thing I see. That was me. I wanted to do CS, but I just didn't really make it in that one. And also, I'm gonna be honest, algorithms are kind of what killed me. I kind of got really. I had a professor that I didn't really like very much. Like I just couldn't really understand his teaching style, and that just made it really hard for me to understand what was going on. And yeah, so that's kind of where I stopped that, and then I went into computer engineering, and that was like where I was like, okay, yeah, this is what I want to understand. This is like I wanted to understand how computers work a little differently. So I learned to like I built like a processor in class kind of thing, and we did that, and that was like 8-bit little emulated guy. That was really cool. And so now that I've come back to it, this feels very similar to that. And like now that I do web dev stuff mostly, I don't really think about this much now. So having this kind of outlet is really it's kind of cool. And it does actually improve like how I think about writing code in Go and other places. So type val is a type. So can we just switch on the type val? Can I do that? We can do this here. Is there something I'm... Oh, okay. So that... I think it's like this. Yep. Expected a comma. Okay, so... Let's see. Can I do this in Vim? Let's see. Let's make a macro. End of line. Comma. Escape Q. At A. There we go. Do we even have a U16 in this at all? We do. Okay. And this is wrong because floats print as decimal values. And we'll do this as well. Duplicate switch value. That's not a duplicate switch value. Let's see. Let's pull that up. Sig switch value. I will pull that over in a second. Do I have to do dot? Let's see. I feel like that doesn't really make sense because it's we do switches on unions and I don't. Oh, do we have to make a type union? Man, what is going on today? Sig type union. Sig switch on type. Switch prongs can be marked as inline to generate the prongs body for each possible value it could have. Oh man. So let's try that. Let's just... Oh, is inline switch not a thing yet? Oh, that's on master. Yeah, we don't want that. I guess I could do it. I guess we could go install the latest version if we wanted to. Inline. Oh, okay, okay. So you inline the value. Okay, inline. 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 Let's see if this fixes it. No. Tagged union. I think we needed... Hmm. What if we do this instead? Pull. Yeah, let's see what's going on here. Switch on an arbitrary expression. Multiple cases can be combined with a comma. Okay, so it's something with this type info thing. Oh, I guess because that's comp time, so it actually doesn't know. So what if we did a union? Let's do a type union. So that would be... Yeah, let's just make a type union. Switch on struct field type zig. Yeah, we'll give this a shot. If this doesn't work, then I'm not going to spend too much time on it. We want a union. Union. I think it's an anonymous union. Yep. Without specifying the type. I wonder if they do that in the Zig source. Zig source. This might be the place. This might be where we... where would it be? Nope, not that. That's not what I'm looking at. I want... that's probably a good place. Let's look in the format docs. So doc standard standard format. Parse float. What about, okay, so let's maybe debug might be another place to look because that does not seem very helpful. Standard, what is it? Standard debug print. And, oh, okay, this is what I'm looking for. Format.zig. Okay, this is the one I want. Argument specifier. Yeah. Compiler, type info. We get the fields. And then we call it recursively, which is the format function. Oh, okay. Format is actually the array. Okay. It has to know something about the type. Oh, dot number, dot named. Okay. Why don't I just use format though? Okay. So then I'm guessing what it is that we need a. Okay. So let's do this. Union. I haven't really done much with union, so this might not work at all. Union. So this would be like number. I wonder if I could just. Hmm. Uint 32. I don't know if I like this. All right, let's just try it. Let's see if it works. And then we'll do string. Let's type string. Can I just do this? Like, can I do U32? Oh, okay, yeah, that's fine. Char, type char. Yep. Then F32. F32. So why we're doing this is we want to create a union to switch on that instead. I think. Can I coerce into a type, into a union? Oh, type coercion. There we go, baby. That's what we're looking for. I guess maybe do I want. Yeah, I want to do this, but I also don't want to spend all my time doing this morning. I want to clean this up instead. So let's do. Yeah, that's fine. Jeez, what's our memory usage looking like? Did it just use a whole gig? Hold on. Oh yeah, it really does eat up that memory. Well, not really. I mean, that wasn't that big. I guess we are loading like the whole file in the memory. So let's see. Cat source source no tests um step 5. Oh, no. Clear. I want to do like an ls 11 megs. Yeah, that shouldn't be that much memory. Well, yeah, no, it shouldn't be. But I guess if we're allocating all of those fields too, uh, it's not a great use of it, but it is doing it. Hmm. Okay, that's fine. Um, let's see. All right. So I think what I want to do is I kind of want to break this up a little bit more. So we want to move the PDB reader out. That needs to be like its own thing. And then the other thing I want to actually look at is they're starting to do packaging for Zig, and I kind of want to figure out how to package this for Zig. Yep. Let's see. Okay. Args. This is the allocator. Um, hmm. How are we gonna do this? Okay, so let's leave that. I do want to change this to print all of the fields. So let's, hello, LSP? Oh, Copilot? Yes, I know Node.js 16 will be dropped. I understand this. All right, let's do yeah, standard debug.print. Yeah, there we go. That's what I'm looking for. That's awful. I don't like that at all, actually. But it'll have to do. I think that'll work though. 3 unused arguments. Let's see. What are the unused arguments? All right. Well, 1, 2, 3, 4, 5, 6. Got it. Yes. 12, 13. 1. What are the fields I'm not using? Invalid format S for type U8. S for type F32. So what fields are that? F32. 1, 2, 3. 1, 2, 3, 4, 5. This should be a char, I think. Record is a string. Serial is a name. Um, self.name is a string. Alt location is a char. Residue name is a string. The chain ID is uh sequence E16. The I code is yeah, let's just keep this as is. This is good enough. We'll add more as we need it. The ones I do want to validate are the char fields though. So let's add the I code. I think these should be fine, but I have a feeling they also might not be. So can I just do like a C? All right, it's not printing them, but that doesn't necessarily mean that it doesn't exist. Let's do a simple one. Let's do test. Does this one have an I code? www.pdb, our favorite. So the I code is bit 27, or column 27. Oh, so it is a number. Hmm. Why did we do it like that, though? Oh, it is a U8. So I should be able to say that that's like a chart, or just a number, right? So when we do the print, I can't tell. Yep, there we go. Okay. So we do have the I. And if we open tests, step 5 assembly. Hmm. Oh, these are. Oh, so this don't even have I codes. Interesting. So it's printing an I code, but it doesn't have an I code. How are we assigning it? I code, I code, I code. Hmm. I think what's happening is that the I code is not set at all. Let's take a look. Optional. Optional. So I think what we're going to do is we're going to add some optional types here because I've noticed that this happens. So let's go to the atom record. We'll do the yeah, so we'll say it's null by default. And then what we need to do is when we do the conversion to the atom record, we need to specify that. So I did that on the I code. So ASCII table. Yep, that's exactly what I thought. Okay. So basically what we're going to do is we're going to say if we're going to do it here. So if the we'll set this to I think it would be else null. Uh, inline if statements, if, else, if expression. I think we can do this inline. Is something I'm missing here? Expected statement found else. Oh, I think we have to do like this. And we need this. I think Ziglings has it. So ziglings.org. I have a feeling that they did it. If two. If statements could also be a valid expression like this. Okay. So this is an assignment one. So we'll say if self.chain. Okay, so let's do this right. Except that's like not the one I wanted to do. We did the I code. Oh, 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 alt location. Oh yeah, so I was right. No, I was not. Okay. Okay. So this needs to be this. alt location is going to be if okay, let's see if this works. It's probably going to crash because it's null. Actually, it won't. Let's try to print it. Okay, also let's try this on the I code as well, I guess. We'll say the I code is an optional value. I guess if it's the default, we don't need to set it. So let's rethink that. Let's do this. If it's not equal to that, it's this. And otherwise, we'll use the default. And then we'll do it for the I code too. So if self expected type U8. How does that one make sense? Oh, I guess yeah, okay, yeah, that really, because that coerces the type correctly. Okay. So we'll do yank to the end of the line. I did that. Yep. It's not exactly what I said, but okay. And then this needs to be I code. Cannot form an optional without specifier. Okay. I'm losing myself in my own file right now. Spent way too much time looking at this. Is it like this? So sometimes it's null, sometimes it's not. Why is that? All right. Hmm. That's weird that like sometimes it works and sometimes it doesn't. Let's run this on a simple one. So I think cat tests other. No, test. Yep. Let's run that on test. Yeah, I don't like doing that on like as space. Let's do that as if it's 32 instead. Oh, that's just like completely backwards. If it equals this 32. Yep, there we go. Cool. So now we should be able to do this and it'll work correctly. Should always be null. All right, cool. All right, well that's good. That looks nice, right? We like this. We like a good null. I feel like people don't, but like I kind of like the null in Zig because you can't do like a null pointer really, at least from my understanding. Like I haven't really run across it, but it's pretty cool. Yep. Yeah. Okay. Cool. So we have the optional types now. Um, what other values are optional in the WWPDB? I think it's the last two, the element symbols and this. So this should help too. The charge, no, the element and the charge. So these two are optionals. So then when we do the conversion to the atom record, it would be, ooh, how would we do that? I guess we would check if the fields are empty, right? So uh, if hmm, that's going to be harder than I think it's going to be. So let's, for right now, just to like not let scope creep kind of happen to me, we'll just do that. Why make the types optional? Um, well, the biggest reason why you might is like I like for example if I don't want them to show up. Actually, here's a really great example of why you wouldn't. Um, let's see. Main.sig. I think it's the place we want to do it. Yep. So we should, in theory, be able to do something like try atom.toJSON. Actually, we need to. This takes in a list. Oh yeah, because I removed the allocator. Oops. Hmm. So the reason that I don't want to is like, for example, and this is for a serialization point, right? Like if an item doesn't exist, right? So like, for example, if we don't have a residue name, then it should be null because then when we try to serialize it into a different format, for example, JSON, that would then mean that we don't like it would actually serialize to like it just wouldn't appear in the JSON, I believe. Now, that's a good thing. Like we don't want that there, like kind of how Go does, right? Like Go, you can if you have a null value in a struct and you try to serialize it, it just doesn't it doesn't appear in the struct if you include them at empty. That's what my goal is that if it's missing, then it shouldn't appear on the record at all. Um, and that's my thought. Because like I don't want to print something that doesn't exist. You know, like I don't want something in my record that doesn't exist. Also, it allows for better type checking, right? Like if I want to call something on a value, I can say like, "Hey, is this null?" And then also null is a type. So let's kind of talk about that for a second. Null is a type like undefined. So yeah, and it's like you get guarantees that it's going to be at address 0. So like it basically adds no size. Weird that you would have to do that. Yeah, I mean, it is, but it isn't. Like typically, like optionals aren't really a thing in like C, for example. You'd have like I guess the closest thing would be like a void star, like a void pointer. This is nice because it's like you get it for free, right? It doesn't take up any memory. That's like the big reason you'd want to do it, right? So then the struct has an empty field that has no size to it. Um, is my understanding. So you kind of get this advantage of like if it doesn't need to take up the space, then don't. Um, is kind of my thought with it, at least. Um, but yeah, yeah, that's kind of like my philosophy when it comes to some of this. Is that like if it's I'm of the advocate that like if something is not shouldn't exist, then it should be no. Yeah, yeah. So my thing is like if you're gonna get it for free, might as well use it, right? And it also kind of creates a contract between me and the user, right? Because I'm saying, hey, if someone's trying to use an Atom record, they can go, this is a char, and I can say, well, actually, the compiler will catch it and go, um, that shouldn't be, the case, right? Like we know that this value is, for example, I don't know. Like we can someone who's trying to use the library can then go, "Oh, this is not meant to be used." Right? Like we know that this might not exist and we need to handle that case. So my thing is I would rather that be known explicitly, right? So that someone who's using this can go, "Oh yeah, that's not going to work." Versus them being like, "Why is this character you know, empty?" Cuz undefined doesn't necessarily mean um no, it's like it's slightly different. Undefined. Um, yeah. So it actually does have like memory, so it's slightly different. But like basically that I kind of want it to be null and optional, so that if it's something that might not exist, that's caught by the compiler, and then also that by extension, then it's caught by the user, right? I find that like as I've started to write more like library like code, I've had to think a lot more about this of like how is someone going to consume my library? How is that going to look for them? And that's been like the hardest part I think of writing library code, right? Like in an application, I'm more concerned with like, oh, how is this going to look to the end user? In a library context, I'm more like, how is this going to work if someone was going to use this in a program? How would I want it to be consumed? And that's like what I'm kind of doing here is like I want these things to be optional because they might be optional. And then like the only other two fields are these two. These are optional. But if we look right, so this is in the Atom record, which is like what the user sees. But on my side, right, for when I'm creating the object, what's actually getting parsed, I don't want that to be. I don't want any of that to be optional ever. Um, because like I want to parse all of the memory as it is. And so I want to have it like I want to have the complete picture that I can manipulate. So then in that case, none of those fields are optional. They can be empty. That's fine. And then I can manipulate them to not be empty when I pass them on to the user. Yeah, but that's the idea. Is we have like these empty types at least a little bit. I think for right now, devil in those details. Yeah, exactly, exactly. And that's the thing though, right? Like that's kind of the advantage of low level programming, right? Is you do have to be very cognizant of those details, but it's also its biggest weakness when you're trying to build something quickly, right? Like if I just want to make it work today, then that that's not going to work as well because like I it's really easy to just not think about things like think things through. Um, Luckily Zig is better in C that like Zig has a lot of safeguards to it. So like it has better like memory knowledge. It has better understanding of like how to build parts of this, and like it can catch a lot of that a little bit easier, which is really great. That's a huge win, right? Um, but the problem with that too is that you run into this issue where it's like, well, it it might fail. And how does that look? So that's kind of where I try to think about it. Is like let's try to do it in a way that we can actually make it so it's usable for other people. And C doesn't afford that to me. Like I mean I know there's usable C out there. You can read the Linux kernel. It is usable C. It is very well written. But that's not what I want to write. That's not like where I don't want to spend my time debugging like that. So I'd rather that the language catch a lot of that for me, which is what I like about Zig for one. Zig is it's I'm learning it. It's definitely one of the harder languages I've learned. Um, I feel that way about Rust and Go as well, though. So yeah, when I'm yeah, in those new low-level languages, there are some niceties, right? And it's all about hindsight, right? Like we didn't know that this was gonna be the problem. I think when they built C, right? Like that's not the thought. Same with C++, right? Like some of the issues that we ran into C++ were not things that were probably considered, right? But that's why I think that being very cognizant of some of this is like what we as developers we kind of we have to we have a responsibility to that, right? Like I kind of have to be aware of the fact that yeah, it had to be exactly. Um, but we owe it now, right, to be like cognizant of some of the mistakes we fall into, and that's why when we're building libraries, we have to be very cognizant of what's going on, and like it shouldn't just be arbitrary. It should be very well documented and worked through. And um, I think that's kind of how we should be writing code, right? Is that we should write it to be a little more intentional. And I think that's like what the point of Zig is, right? Zig is kind of written with the idea of like let's write code that's a little more intentional. Let's write something that's a little more, you know, low level, but like that just because it's a low level doesn't mean that you shouldn't get all the advantages of modern programming, but also you should have the choice still that you get with C, right? I should be able to choose how I want to allocate my memory. I should be able to do that. And we've seen actually through this process that actually having the ability to manage my own memory did actually provide us with some like sizable um some real performance gains, right? With like page allocation, right? We got a lot faster allocation using paging, using an arena allocator instead. So that's kind of my 2 cents on it. But yeah, yep. But I think this is kind of in a good spot for the printing stuff. I'm fairly confident that it'll actually work now. The next thing is I want to move out the parser, I think, because originally that wasn't the case. So I think we're gonna move this into records. Um, to an array list. Yeah, we can change this to like PDB reader. There's some other stuff that I think if we were actually going to use this for something, we would probably want to do more like association between the values. Um, that's something that I've noticed on some of the other parsers we're comparing against is that they do some sort of association. Maybe we'll look into that, but right now I just want to focus on this. All right, cool. So that's done. I guess we can move that. So let's do this. Const uh, PDB reader. Nope. Actually, that's not the case. It's going to be records.zig. And that's that. And then we can do this down here. Should still work. I hate that this happens. I need to see what's going on there. And then this would be this. Yeah, we don't want to. We won't do the 2JSON. You have to. I need to rewrite that, to be honest. I wrote it in a way that like you basically allocate all of the array ahead of time, and I don't really want to do that. So let's do this instead. Let's make sure this one works. Yeah, there we go. There it is. Cool. Yeah, I'm also considering moving this part, the file parsing part, from an arena allocator to an arena plus page allocator, so that we can get larger bytes at the same time. Because if we're reading in like 11 megs at a time, a page allocator might work better. So let's look at Zig page allocator. So we get the heap page allocator, and then we allocate the bytes for that. So what I think we could probably do is, and then the arena allocator, we can initialize it with a heap page allocator. So rather than using the general purpose, we'll do standard heap page allocator. Not much different. If anything, it's probably a little slower. Let's do this like right. Let's do this like with 10 runs. Okay. So let's say we. Oh, you know what would be really fun? We should see if we can compile this to WebAssembly and do it in the browser. That would be interesting. Let's look at that. Zig Wasm. What are you talking? Wasm is so much fun. It's great. Release small target Wasm 32. Do I have Wasm time installed? Wasm time. I do. Let's see. Zig build exe. Let's do release fast target. Let's see. Do I just target it as Wasm32? Oh, is it Wazi? Okay, Wasm32. Wazi. Expected type U size found U64. Yikes. Oh, right. What is the size? Oh. Can I coerce it into a U size? Yep. Yeah. Oh, okay. Yeah. So I guess we could probably do the library part, but I don't think we can do the file part, right? Because that's expecting. Okay, maybe not today then. That'll require some more work. I know what I have to do for it, but yeah, that'll be cool. All right. Well, I think that means we're in a pretty good spot. I think what the goal is going to be is we'll move the records and strings file into its own thing, and then what we'll try to do is we'll do Zig parsing, or we'll do the Zig packaging stuff to try and get that so that we can import it as a library instead. But I think I'm confident that we can do git init dot git status nvim dot git ignore star.csv main dot o nvim dot git ignore zig cache. I think for right now we'll leave tests out because they're kind of big files. Get LFS. Yeah, we'll use get LFS at some point. Get add.get attributes. Yep. Yep. I did that actually. I had that problem on my website. I hosted it on Git. I use GitHub to like manage it. Yeah, that happened to me. I did that too. I mean, it wasn't like that big of a history. It was like maybe like a month. Like it wasn't even that much, but it was enough hassle for me to never do it again. Um, but I guess what we'll do is we can do git. Do I even have it installed? Okay. Git lfs track star.pdb. Actually, I don't know if I want to do that yet. We'll add it. Yeah, I don't know. We're gonna because I need to make sure I don't want to put unedited ones in there. So let's keep this as it is right now. Git add build.zig dot git ignore. Nope, not git attributes. Source. Do we really just want to call it fast PDB? Do we have a cool name for this? Alcius? Yeah, yeah, I hear you. Ooh, that's a good one. That's a good one. I like that. A PDB parser and NZIG. Cool. Um, a sonic speed PDB parser. Uh, Sonic parser. Sonic. Oh yeah, Sonic PDB parser. A sonic speed PDB parser written in Zig. Let's a work in progress. Sonic speed written in Zig. The advantage to using Zig though that's like actually really cool is we do get cross compilation out of the box. So the cool thing about Zig's compiler is we can compile it to things like Windows and Mac OS with its compiler, even though it's like C or C adjacent. But we can compile to both, which is cool. We can compile and test with that in Kimu, which is awesome. So it is kind of a cool project. All right, enjoy. Good luck in your reading. Thanks for hanging. I'm gonna get this up on the Git, but have a good one, and I'll see you in a couple weeks.